Imagine trying to mail an entire house through a standard curbside mailbox. It's physically impossible to send something that massive all at once. Data communication works on a very similar principle. At its core, it is simply the act of sharing a message between a sender and a receiver. To make that happen, a network needs three basic foundations. You need the message itself, the data, you need the physical roads it travels on, the channels, and you need a common set of rules so both sides understand each other, the protocols. But here is the central problem. If you tried to send a massive file, like streaming a 4K movie, as one giant continuous piece, it would monopolize the entire road. No one else's messages could get through until your movie finished. For the internet to actually function for billions of users at the exact same time, networks need a way to let everyone share the road without creating a massive digital traffic jam. The solution is never to send data as a single giant object. Instead, the massive file is sliced down into thousands of tiny, manageable pieces. These tiny pieces are simply called packets. When your computer sends a file, it deals with these small, standardized blocks of data. But chopping a file into thousands of pieces creates a new challenge. Just like a real physical package, every single one of those digital pieces needs its own shipping label so it doesn't get lost in transit. In networking, this vital shipping label is called the packet header. This slide breaks down what a packet header contains. It includes a description, the destination address, and the source address. With this routing information securely attached, every packet becomes a self-contained unit, finding its own way across the internet. This creates a huge logistical advantage. Because packets are small and independent, they can intermingle freely. Packets from an email, a video game, and a movie can all seamlessly share a single communications channel. This packet system allows the internet to handle everyone at once, letting billions of messages share the wires without getting stuck behind massive files. But how do those tiny packets actually navigate the maze of global network cables to find your specific computer? That is the job of a router. You can think of a router as a highly intelligent digital sorting facility located at every major intersection on the network. This diagram illustrates how that hardware operates. When a packet arrives at an input port, the processor reads its header to find its destination. Instantly, the processor triggers a switch, redirecting the packet to the correct output port for its next leg. This diagram shows how routers connect endpoints through complex networks. With multiple possible routes connecting point A to point B, a router can detour packets down an alternate route if a cable breaks, ensuring data keeps moving. Sometimes data needs to cross between two completely different kinds of networks. In those cases, it passes through a gateway, a specialized router that acts like a border crossing, updating the shipping labels so the new network knows how to handle the delivery. Without routers constantly reading those headers and flipping switches, the entire system would grind to a halt. They are the active infrastructure that guarantees delivery. This massive sorting and routing process is happening simultaneously across the globe, billions of times every single second. When all those independent little packets finally arrive at your computer, they seamlessly snap back together to rebuild the original file. Because the pieces often arrive out of order, your computer looks at the sequence numbers tucked inside those packet headers, knowing exactly how to arrange the data block by block. And if one individual packet gets lost along the way, the system is efficient enough to simply ask the sender for that one specific missing piece. You don't have to restart your entire download from scratch. Every video call, every single email, and every website works because of this invisible relay race of tiny packets and smart routers. By chopping messages into pieces and letting routers guide the way, the system keeps the digital world moving one delivery at a time.